Hello everyone, so now I'm going to explain the task 7.3D of embedded system. In this task, our objective was to create an embedded device that utilizes the Raspberry Pi's PWM pulse width modulation capabilities to provide real-time feedback based on the proximity of solid objects. The core idea behind this project was to employ ultrasonic sensors to detect the approach of an object and communicate this information to the user through various sensory cues. I chose to work with an LED as my primary output device. As objects come closer to the device, the LED responds by increasing its brightness, providing a visual indicator of the object's proximity. This project effectively demonstrates how PWM control can be used to modulate the brightness of an LED, allowing it to act as a proximity alert system. Now, the hardware components being used in this task. First is the Raspberry Pi, ultrasonic sensor, HCSR04, LED, and some of the jumper wires. Now this is the code for my task 7.3D. Before moving on to the code, I'll explain the hardware connections required for this task. Now for the hardware connections, the negative pin of the LED is connected to the ground of the Raspberry Pi. The positive pin of the LED is connected to the 12 of the Raspberry Pi. Now for the ultrasonic sensor, the VCC is connected to the 5 volt of the Raspberry Pi. The ground is connected to the ground of the Raspberry Pi. The trig pin is connected to the 8 pin of the Raspberry Pi, and the echo pin is connected to the 10 of the Raspberry Pi. Now for the code, first I have imported some of the necessary libraries rpio.gpio for working with the RPI Raspberry Pi's GPIO pins and time for time related functions. Then I have set the GPIO pin numbering mode to gpio.bcm. Then I have defined GPIO pin numbers for the components LED, ultrasonic sensor, and ultrasonic sensor trig pin and ultrasonic sensor echo pin. Then I have set the maximum distance in centimeter. This value is used to determine the LED's brightness based on the measured distance. Then I have set up the GPIO pins. GPIO trigger is configured as an output pin for sending the trigger signal to the ultrasonic sensor. GPIO echo pin is configured as an input pin for receiving the echo signal from the ultrasonic sensor. LED is configured as an output pin for controlling the LED. Then I have created a PWM object for the LED. This allows us to control the LED brightness using PWM. The 100 specifies the frequency in hertz of the PWM signal, and the LED dot start initializes the LED with a duty cycle of 0, that is LED off. Then I have defined a function named distance to measure the distance using the ultrasonic sensor. Then I have triggered the ultrasonic sensor by briefly setting the GPIO trigger pin to high and then to low. This initiates the measurement. Then I have initialized some of the variables to record time, that is the start and the stop times for measuring the echo duration. Then the while loop, we in this while loop we wait for the echo pin, that is GPIO echo, to go high, making marking the start of the echo signal. Then we wait for the echo pin to go low, marking the end of the echo signal. The time elapsed, then we calculate the time elapsed between the start and the stop of the echo signal. Then we calculate the distance based on the time elapsed and the speed of sound. that is 34300, which is divided by 2. The division by 2 is necessary because the sound travels to the object and back, then we return distance from the function distance. Then I have implemented some of the try and catch try block to handle some of the exceptions. Then the LED stop, it stops the PWM control of the LED and the GPIO dot cleanup to clean up and release the GPIO resources used by the script. Now we'll run the code. So now when I run the code, then the LED will glow only when the distance is less than or equal to 10 centimeter, because I have set the maximum distance to be 10. So now for the LED, when the object is approaching very near to the sensor, then the LED's brightness will be maximum, and it will be accordingly for when the object is far away from the sensor.